Hello everyone, my name is Hashneet Kaur and today I'm going to talk about my project Movie Rating Prediction. The research question for my project is, can the rating for a TV show or movie be predicted based on its features such as title, director, its genre, and its description? By TV rating here, I mean the rating given to a show or a movie by the TV rating system to give parents more information about the content and age appropriateness of any particular show or movie. So let's look into it. The data set that I've used for my project is the Netflix movie and TV shows data set, which is available on Kaggle. The size is about 1 MB, has 7787 unique rows and 12 columns. These are the different columns that are available in my data set. My column rating is my target variable, and there are a couple of columns like director, cast, country, and rating, which has some missing values. So what were the steps followed for this project? The first was pre-processing the data, getting the data ready so that it can be modeled. Step 2 was hyperparameter tuning and finding the best model. Step 3 was predicting on the unseen data and model evaluation. And final was my final analysis. Let's look into all these in more detail. My step 1, which was data processing, the first process step in this was to find the list of feature variables which we wanted to use for modeling. And these are the variables that I'll be using: type, title, director, etc. Step 2 was to deal with the missing values. I imputed the missing values with a string unknown. Step 3 was to change these feature variables or categorical variables to numeric. For that, I used one-hot encoding, which converts these category variables into zeros and ones. Step 3 was to deal with my text columns. The column listed in and description had a lot of text, and I transformed that text using the TF-IDF factorizer, which transforms these text columns into feature vectors. Now, step 2 was model selection. For model selection, I used the randomized search cross validation. For randomized search cross validation, I define my search space in which I list all the models that I want to test. I give all the hyperparameters for each of these models that I want to try. My randomized search CV randomly picks up hyperparameters for each of these models and gives me the best model. The different models that were tried for this project are: first is random forest. These are the different hyperparameters that I tried for this model. This is extra trees classifier for hyperparameters tried for this. And the last is linear SVC. And these are the hyperparameters tuned for this particular model. The best model given by randomized search CV was random forest with the hyperparameters and estimate 274, max features as square root, and criteria as Jenny. So using this best model given by randomized search CV, I did my predictions on the test data set. And to evaluate my model, I compared these predictions given by my model with the actual values for the test data set. For my model evaluation, there were different metrics that we're using. The first matrix that I used was a confusion matrix. Now, the confusion matrix gives me my true positive, true negative, false positive, and false negative. The diagonal values of the confusion matrix gives me the true positive, the values which are truly identified. My rows gives me the actual labels for all these observations, and my columns are my predicted values for these observations. There were some very interesting things that I noticed in the confusion matrix. For example, a lot of 6s were identified as class 8. A lot of 9 was identified as class 6 and class 8. So let's look into this further. One, obviously, we can see through the confusion matrix that a lot of classes were wrongly predicted. Now, class 6, it corresponds to my movie rating of TV 18, which means that the content is unsuitable for children under 14 years of age. While class 8 is that the content is unsuitable for children under 17 years of age. We can very clearly see that these two categories are very closely related to each other. And that's probably exactly why my model got confused and predicted a lot of 6s as 8s, and vice versa. Similarly, for class 9, which is parental guidance suggested, it's a very broad class. So a lot of 9s were predicted as either class 6 or class 8. Another question that came to my mind is, why is most of it being predicted as class 8 and not any other class like class 6 or class 9 if they are interrelated with each other? That's because a lot of data is available for class 8. So probably wherever the model got confused, it predicted it as class 8. Also, class 8 is a very general class. It has the shows and movies from all different categories. So a lot of other classes was wrongly predicted as class 8. Another matrix that I used for my model evaluation is classification report. In classification report, I can see that the accuracy for my F1 score, which is 0.54, is not too high. While some classes had a really good recall, for example, class 8, which had for which the value is 0.86, while for class 5, it is just 0.39. What was my final analysis from all this? The accuracy of the final model is definitely not too high. The ratings from this model cannot be effectively predicted. A lot of incorrect predictions have been made. What could be the few reasons for this incorrect prediction? The given features, the given data that we have is not enough. Probably there are some external factors that need to be considered while giving movie ratings, which are not mentioned in the data set. Also, the data for a lot of classes is not enough. Some classes have a lot of data, while for others, we do not have a lot of data. What could be the future improvements for this project? We could recast these target variables into something which can help us segregate into between these ratings more strictly. Second is that we can reframe this as an ordinal regression problem, change this target variable into ordinal regression and try other models. And the last thing that we could improve is that add more content information. We could add more features, for example, the parental website reviews, etc., which could help the model predict more effectively between these different ratings. That would be all. Thank you.